Hello everyone, welcome to the presentation on Player AI Interaction, what neural network games reveal about AI as play. My name is Jennifer Villareale, a PhD student at Drexel University. Literature on human-AI interaction is among one of the fastest growing fields in the Chi community. With few exceptions, most recent literature focuses on productivity-related domains. However, one overlooked area is the context of play. The history of AI has long been associated with games. Video games have often been the testbed to try new AI algorithms and use the user interaction they afford. Therefore, games offer a rich domain to understand and explore new ideas in human-AI interaction. In this work, we study the interaction in neural network-based games. With this, we propose the new research area of player AI interaction. In our paper, we showcase how the concept of play can expand the current discussions around human-AI interaction and point out new opportunities for AI-infused products in general. We chose to use neural network games because they provide insights into some of the most pressing open problems in human-AI interaction, such as the low interpretability of the machine learning models. These are the methods we used. Through the first systematic review in this domain, we collected a dataset of 38 games wherein players can interact with the neural network as part of the core gameplay loop. Then, using this dataset, we used grounded theory to develop a framework for how players interact with the neural networks and how much its existence is foregrounded in the user interface. To compare player AI interaction to the broader discussion in other AI products, we also adapted existing guidelines for human AI interaction and used them to evaluate our games. Our analysis found 4 interaction metaphors that provide familiar structures for players to interact with the AI: apprentice, competitor, designer, and teammate. For example, the game AI Evolution uses neural network as teammate metaphor, where the player interacts with the neural network as a colleague. The focus of the gameplay is a collaborative cycle between the player and the neural network where they both work together towards a shared goal. Players are able to build hilarious-looking neural network creatures, and they're able to construct their brain and the avatar structure in order to train them to compete in a race. This is a new kind of interaction we typically don't see outside of games yet, playful interaction that motivates players to try different kinds of AI configurations. We also found that there is a range of how much games highlight the use of neural networks in their user interface. This visualization represents the design space of player AI interaction based on these 3 dimensions. Each dot on this outer ring represents one of the 38 games. This diagram helps us identify underexplored areas. For example, we noticed that all games that adopted neural network as apprentice interaction used online learning for player agency, such that the player may play with or control the training of the neural network. This interaction leads to a variety of neural network behaviors, whereas most other metaphors use offline learning for a more predictable player experience. We compared the compliance with these guidelines across the characteristics of our framework. Most notably, we found that neural network as apprentice games comply well with the guidelines, particularly with regards to providing global controls to the user and learning actively from the user behavior. For games where neural network is represented as a competitor, the compliance with the design guidelines are very low because the guidelines are not created for the cases where AI is an adversary. However, an increasing number of AI-infused products would fall into this category. We also compared the design guideline compliance of neural network games with the reported outcomes of AI-infused products by Amershi et al. To see what key similarities and differences exist. We find that, like other AI-infused products, neural network games struggle to make the limitations of the AI known to the user during the initial interaction. However, games do this intentionally, as the point is to learn the limitations through play. Neural network games generally perform better in enabling the user to provide feedback, indicating their preferences during regular interaction. They are also better in allowing the user to globally customize what the AI system monitors and how it behaves. For game designers, UX designers, and HCI researchers interested in human-AI interaction, one of our key takeaways is that reframing AI as play offers a useful design approach. AI as play can offer a new design space where users can tinker, explore, and experiment with AI. With that, we would like to thank NSF and DFF for supporting this work and the anonymous reviewers for providing their comments. Thank you for joining our presentation. If you have any comments, feel free to reach out via Twitter or email.